So, today we will be talking about input output. Okay. Very often I refer on the first day's class. Okay. So, today again we will start with the first day's, that block diagram of computer system, and then we will be talking about which portion, and if possible today I will finish, otherwise we will continue in the next class. Okay. So, it was slide was prepared nicely, at least I can tell. Okay. So, what is the learning objective of today's class, and then we will go look back, and then we will see that generic model of the IO module and so on. Okay. So, here we go. These are the learning of questions and learning objectives. What are the objectives like? We may have often questions like, how does a bulk of data get downloaded from internet to the local disk? Okay. So, how does data transfer happen while watching a movie from CD, DVD or from OTT platform? Okay. And which functional unit of computer system responsible for this activity? So, answer of this all question is direct memory access. So, there is a technique is called direct memory access, through which we easily transfer huge volume of data from IO device to memory of the computer system. Okay. So, that is the main theme of today's class. So, we understand the operation of DMA, but maybe it can be delayed. We will be discussing next class on DMA, but before that we need some little background, and then I will be talking about that. Okay. So, this is a famous diagram I have been talking quite some time. So, that is the block diagram of computer system. So, block diagram of computer system, we have talked about ALU extensively before mid sem, no question will be there in the end sem. Okay. So, here then we talk about memory. Okay. So, obviously question will be there in end sem here. So, and then we talk about control unit and microprogram control, not hardware control. Okay. So, we touch upon these all the parts, but we hardly talk about the input and output. Okay. So, that is today's class we will be talking about how the data are computer accept inputs and then it output to the output device. So, this is the generic diagram here. We know the address line, and then we have the data line and control line all together. We know these are called the system bus. System bus will be connected to the IO module. So, IO module it is a hardware, and it basically connects with multiple IO device, like there should be a some hardware. So, where say let us say we will have connection to printer, we will have a connection to keyboard, we will have connection to mouse and so on. So, that thing is something called IO module. Okay. So, IO module act as interface between the system bus and the peripheral. Okay. And as you know, other end of the system bus is nothing but you have a processor. Processor means you will have the ALU and control unit, not the memory. Okay. And again memory is another part we have seen just previous slide. So, to connect the with memory, so that IO module has to go to the data line, address line and so on, that we will be seeing how data is transferred from here through here, here and then here to the main memory. So, that is the task of the DMA. But what we want, data should be coming from keyboard to the processor. So, that how it works also, that we will be seeing. Okay. So, IO module basically control the peripheral devices. So, next we will be talking about little more within the IO module what we have. So, we have a data register, and then we have control or status register, and this will be connected to the data line. What happens, say suppose CPU wants to read data from a IO module, let us say from the keyboard. So, then say let us say it wants to write to, or it wants to show to the display. So, therefore, it will send the data to the data register, which means what data it should be written. So, and then it should be status of the status word, it will read, it will communicate with the IO module, other device, whether this printer is ready or it is not ready and so on. So, it will check through this register. So, module connect to the other component through system bus. Okay, these are the system bus, like we have address line, control line and data line. Say suppose CPU wants to write it. So, therefore, it should inform. So, this is the write operation, okay, or it is a read operation if it wants to get data from the output device, okay, or input device. So, therefore, module connects with the other component through system bus. Module buffer data using data register. So, obviously, so if the data is coming from, let us say, from input to the processor, so it can be buffer here in data register. There may be multiple data register. Status register is used to status information of the concerned device. Say suppose whether printer is ready or not, that should be checked through the status register by the CPU. Control lines used for the communication with CPU, as I said that this is the write or read operation, and then it will inform data, it will inform to the that which device it wish to access through the address line. Okay. I think this it should be unique here, that I will check it this part. Okay. So, and then it will tell the what is the status of the device, and then it will transfer the data. So, these are the thing, but as I said, there will be a multiple device will be connected. Just previous slide we have seen that within a IO module there will be multiple devices. So, therefore, so this will be one external device, this will be another, and therefore, will be connected to the another within the IO logic device. This is also a hardware. So, through which what will happen, it will select any one of them, and then it will transfer the status whether that particular device is ready or not, and then CPU will read yes, this device is ready, and then transfer will happen. Okay. So, this is the generic block diagram of the IO module. Now, what are the major function of the IO module? Obviously, control it, coordinate control and timing, coordinates the flow of traffic between internal resource and the external device, processor communication, device communication, and the data buffering, as I said just few minutes before. So, these are the major function of the IO module. Okay. So, book is like I am teaching book from the Stallings. So, for transferring data from the IO module, it can be IO device, it can be keyboard, it can be say mouse, or it can be from say let us say pen drive to for any IO device to the processor. So, there will be three techniques. Okay. So, one is something called programmed IO. So, here data are exchanged between the processor and the IO module. So, when the processor issue a command, it must wait until the operation is complete, and IO module does not take any further action to alert the CPU. What does it means? Let us say I type A. Okay. So, then in programmed IO what happened? The processor will wait, it will take the data from the data buffer register. So, we have seen here. So, I will place the data here, okay, and then it will see the status, and then it will take out the data from here to data line. Okay. And CPU will continuously wait whether the device is ready. If there is a data, it will take out the data. Okay. So, CPU is only doing this work. Okay. CPU will always involve for the checking the status. If it is ready, then it will take out the data, and then similarly if you want to send the data, it will check out whether the device is ready or not, and then it will place the data, and then data will go to the IO device. So, here CPU is involved for data transfer and so on. So, this is something called the IO module, sorry, programmed IO. So, but problem with programmed IO that CPU is doing everything. In a sense, it is waiting for the slower device, that is IO, until or unless it places the data. But what could be done within this time period, CPU could have done some other work. So, whenever data is available, then it can take out the data. So, but in IO, programmed IO, it is not happening. So, therefore, it further better input output communication is the interrupt driven IO. So, here what happened, processor issue the IO command. So, processor wants to read data from a particular device, let us say keyboard. So, it issue the read command. So, I want to read it data. Now, what happened that IO module So, now from through keyboard to it will go to the IO module, and IO module when it is ready with the data, IO module inform to the processor. So, I am done. So, data is ready, now you can take out the data. So, therefore, in between what CPU can do? CPU can do some effective work. Okay. So, that is the in case of the interrupt driven IO. And in case of the direct memory access, so that is the extreme faster way for transferring data from the IO module to the CPU or main memory. Like no need for intervention of the CPU, only little interventions of CPU is required, but rest of the thing will be done by the IO module from the IO device to the main memory of the system, but it will use the same system bus. So, that is the extreme case for the direct memory access. Okay. So, these are the three techniques are used for transferring data from IO module to memory or processor. So, we will be talking about these three little more details. Okay. So, what happened? The processor directly involved in the entire process of the data transfer, unlike the other two cases, where just it issue the read command, and then whenever data is ready it will inform, and then it will take out the data. But in last DMA is actually only CPU will issue the command that it wants to transfer data, say 5 KB or 10 KB data it wants to transfer from which place to where in the main memory, that part will be informed, and then rest of the thing will be done by the IO module. So, IO module will perform the requested action and place information on the status register along with the data in the data register. So, it is ready and you can take out the data, but it will not do anything, it will not inform to the CPU that I am ready with the data. It is entirely depends on the CPU when it will take the data. So, CPU check the status and take away the data from the IO to the data bus and subsequently to the memory. So, it will go to the data bus and then it will go to the memory. So, that is something called the programmed IO. Okay. I will be repeating same thing here. So, again here there are 4 types of IO command that IO module may receive when it addressed to the processor. One is used to activate a peripheral device and tell what to do, whether it should read the data, and if it is from which position. Let us say if you have a tape, okay, so it should rewind or which portion, or it will inform that from which portion it should read, processor will inform. So, that is something called control. Okay. So, used to activate to peripheral and tell it what to do, and test it. So, it's used to test various status condition associated with the IO module and its peripheral, and then it reads and write operation. So, now this is one thing to mention is the IO instruction. So, for performing say transferring data, so CPU has to perform some it should execute some instruction, because everything is instruction here, right. So, therefore, we should have a IO instruction. Okay. So, now this IO instruction can be two type in a sense, like each device should have an address. Okay. Otherwise, how that processor will identify that I basically want to read from this device, like in a keyboard or from a mouse and so on. So, each device will have a unique address. Now, there will be mapping of these addresses IO device in two way. One is called the memory mapped IO, another is called IO mapped IO or isolated IO. Okay. So, in case of memory mapped IO, so device is considered as a memory location. Okay. So, let us say memory location, as you have seen that memory location, it will have some address and then it will have data and so on. And then to read data, say let us say what is that, add, let us say A is a memory location and we want to store the value R is a register. So, therefore, add is an instruction, A is a memory location, R is a register. So, if it is actually basically take out, it wants to take out the data from a device. So, it will treat as that device as a memory location. So, therefore, what we can tell ki, so let us say we can write store the value of A is a device to accumulator here. So, then whatever the value is there in the device, so it will be stored in the accumulator. Same instruction for memory and same instruction will be used for the IO device. So, that is something called memory mapped IO. Okay. So, here there are, so IO mapping there are two types, one is memory mapped IO, another is the isolated IO. So, here device and memory share the same address space. Okay. So, if the memory has 16-bit address, so IO device also will have a 16-bit address because it is sharing the same address space. So, IO looks just like memory and read and write, like in Linux everything is considered as a file, if directory is also considered as a file. Similarly, everything is considered as a, everything will be considered as a memory, whether it is memory or it is IO device. Okay. So, another angle is like isolated IO. So, you separate from the IO to the, you separate from memory and the IO. Okay. If it is 10 bits for IO, so device address will be different and this address will be different, and then instruction also will be different. Earlier instruction for in memory mapped IO, so instruction for accessing memory, it will be remain same for the accessing from the device, okay. But in case this will be different. So, we will take one example here in the next slide. Let us say this is one example of the memory mapped IO. Okay. So, what is this? Let us say you have a register and register address is 517. So, and you have a keyboard input data register, so another is 516. So, you consider this part 200, load accumulator 1. So, accumulator is a register, so that is inside the CPU. Okay. So, here it will be load 1. Okay. Let us say we write 1 in the accumulator, that is in the CPU, that is the first part. Next is store accumulator to 517. What does it mean? Store accumulator content to the 517, 517 is this one. So, therefore, this position it should be 1 and rest will be 0. Okay. So, now load accumulator 517. So, now what happened? First store accumulator to 517. So, it is storing this value, and now what happened? 517 is actually a status register. So, it will also the IO device also will write to the 517. So, if it is ready, so IO device will write here 1. Now, processor should read this status. So, therefore, next part is load accumulator 517. What is that? So, whatever the value is there in 517, that should be loaded with accumulator. So, now whatever the content is 1000, that will go to the accumulator. So, now within the processor will understand, so this bit is 1. So, therefore, now it will take out the data or it will place the data into the data buffer register. So, then 202 again it will go to the load accumulator and it will continue and so on. So, what you need to notice here it, if I do any operation with the memory, I will also use the same instruction load accumulator or load accumulator. So, let us say I will write key load accumulator with a memory location, let us say 1000. It is the same thing, instead of 1000 I will write key 517, which is the address of the device. So, but if we go for the isolated IO, I will have a different instruction for that will be different from the memory access. So, we have a load IO. So, this is the different test IO and so on. So, in summary, we have two mapping scheme for the IO address. One is called the memory mapped IO, another is called isolated IO or IO mapped IO. So, in case of the memory mapped IO, so it will share the address space of the memory. So, therefore, all instruction which could be applied for the memory access, that also will be used for accessing the taking out or reading to the device. So, device will be treated as a memory location. In case of the isolated, it is different. For isolated, we will have a different address space and memory will have a different address space. So, now next we have talked like programmed IO. Programmed IO is problem is always CPU will check whether status bit is ready. If it is ready, it will take out the data. So, CPU cannot do any other operation until or unless entire input data is stored into the CPU, and then it can go for the processing. But interrupt driven I/O, that is the problem with the programmed I/O, is that the processor has to wait a long time for the I/O module to be ready for either reception or transmission of the data. So, therefore, what is done? We can go for the interrupt driven I/O. So, interrupt driven I/O is the alternative, is for the processor to issue an I/O command to the module and then go for some other operation. It is like some other operation it should do for maybe for the other process. So, this is more details, as I said, the same thing I will be repeating here. So, this is from the programmed I/O, this is for the interrupt driven I/O, and this is for the DMA. So, issue read command to the I/O module, and it will read the status of the I/O module. If it is ready, okay, then it will check the status. If it is ready, then it will read the data available on the status data register, and it will continue. If it is not, and then again it will go to the so it will check the status. If it is not ready, then keep on doing, and within this time period what will happen, that I/O module will take the data and it will place to the data register. So, keep on doing this part. Okay. So, this is, it has drawback as we have seen, then it is better wait for interrupt driven. So, CPU will issue and it will go for some other work. Now, whenever data is ready, so then it will interrupt system and then it will do that way it will go, and extreme case is the DMA. So, again I tell this drawback, that both from the I/O suffer from two inherent drawbacks. So, that is I/O transfer rate is limited by the speed with which the processor can test and service a device. Okay. And processor is really tied off in the managing of the I/O transfer. In case of the, even in case of the interrupt driven, so interrupt driven means I/O device only inform that I am ready with the data, but now it is your responsibility to take the data from I/O module to the data line, and then it will go to the processor or memory. So, therefore, processor is directly involved for transferring data from the I/O module to the memory or processor. Okay. But in case of the DMA, when we wish to transfer a huge volume of data, so in that case we need to have the technique is called the DMA, that is something called direct memory access. So, DMA module takes over the responsibility of transferring data from the CPU. In earlier two cases, CPU was transferring data from the I/O modules, data register to the processor or memory module. Now, DMA module take over the responsibility. DMA module is same as the I/O module, but we gave the name the DMA module. It has a different function. Okay. But logically, it will also transfer data, but the responsibility of transferring data from the CPU is taken over. Okay. So, that is the DMA module takes over the responsibility of transferring the data from the CPU. DMA module force the processor to suspend the use of system bus temporarily. So, now as you know that when you need to transfer the data from the I/O module to memory, so you imagine the diagram when I think this is I said. So, we have a data somewhere here. So, I want to transfer from here to this memory, that is the task of the DMA. Okay. Let us say this is direct memory access module. Okay. So, data will go from here and through data line, and then it will go here. So, it will basically bypass the CPU. So, that is the task of the DMA. So, but as I said, the whenever you need, say let us say when you start watching movie, okay, that CPU will first initiate that data need to be transferred from say your secondary device or say pen drive to the main memory. So, CPU will initiate that this much of data is actually you should transfer to which location. It will mention that how much volume of the data and where it will be transferred. These two things will be informed to the DMA module. Now, DMA module will transfer the data from here to here, but please note that data lines means this data line also CPU will use while executing some other instruction, because it has to fetch the data from the memory. It is the same memory and it will use the same data line or address line. So, therefore, what will happen, CPU process also depends on the same address and data line, and DMA also will data transfer will happen through the data line. Okay. So, therefore, it cannot go parallelly. Therefore, what happens sometime when DMA is transferring data, DMA has the ability to suspend the operation of the CPU for the time being, okay, for a cycle only, but you cannot suspend for quite some times. So, that is something called is like within a cycle ask CPU, okay, I cannot give you right now the data, I am using it. So, you suspend the operation. So, it will suspend the operation whatever it is going on. But please note that whenever it is in decoding phase, CPU does not need the data to be used, data line to be used. So, that time it will not be suspended. When it will be suspended, whenever CPU needs to access the any information which is not there within the CPU. So, it may be the accessing from the memory. So, in that case it needs the address line and data line, that time CPU will be suspended for a while. Okay. So, that scenario is called the cycle stealing. Okay. So, DMA module will force the processor to suspend the use of system bus temporarily. So, this incident is called the cycle stealing. Okay. So, within the cycle actually if you would have taken 5 cycle to execute a instruction, so it will take one more cycle. Okay. So, that is the part that DMA does to complete the operation of transferring data from the IO module to main memory. So, as I said that CPU should issue whether it wants to read data or it wants to send it wants to upload the file to the some other server. Okay. So, that is something called write operation. If you want to download, so that is the read operation. Okay. So, and obviously address of the IO device, and CPU will tell from which device it will go to where, and then it will say that starting location of the memory communicated over data lines. So, it will tell that which portion it will be uploaded. So, that should be mentioned that it is a 1 KB or 2 or 1 GB or so on. Okay. And number of words. So, that is the size and then location. This should be informed by the CPU, and then CPU will go for the some other work. Okay. So, now rest of the thing will be done by the DMA. Okay, these are the information it should pass it, and then there are some operation will happen. So, that is the operation of the DMA. Okay. So, now I will go to the this part. Okay, that is something called DMA break points, that in at which point cycle stealing may happen. So, this is the processor is trying to access the what? It is trying to access the address and data line, right, because it is the fetching from the memory. So, at that point CPU must be suspended. Okay. So, next when instruction is getting decoded, it is within the CPU. So, obviously, there is no question of suspension of CPU. Okay. So, again what will happen, operand fetch within the decode, actually again you can divide decoding, and then if it needs some operand, so again operand has to be fetched from the memory if it is memory is involved. So, there is a chance of here CPU might be suspended. Next, when instruction is executed, there is no chance because it is within the CPU. So, therefore, no chance of suspension here. Again store the results, because results could be written by back to the main memory from a processor. So, therefore, there is chance for suspension. So, these 3 points actually CPU could be suspended. That means, when CPU is trying to fetch the data, so it can be shift one cycle, then it will be allowed. Okay. So, this point is something called the DMA break point. Okay. So, another thing I said, so we had actually 4 phase pipeline. One is fetch, then decode. Within decode is operand, fetch also. So, fetch, decode, execute and write back, that is I said. So, apart from that, there is another phase is something called the process interrupt phase. What happened actually, after executing the write back, processor will check is there any interrupt or not. So, that is something called interrupt phase. So, this is something called interrupt break point. So, while executing fetch, decode and execute, if interrupt happen also, processor will not check. Processor will only check after storing the current execution. So, therefore, so let us say when you are doing some work, now if your phone call comes, so it depends on the emergency whether you will attend immediately. Sometimes what you do it, first we complete this work and then we will attend the phone. It is the similar thing when executing an instruction. So, processor will not give attention to attend the interrupt. So, after completion of this part, it will check there was any interrupt or not. So, then only it will attend that interrupt. So, that is something called interrupt phase, and this breakpoint is called the interrupt breakpoint. So, here is idea is like what I said ki when DMA is transferring data from IO device, let us say you are watching movie. So, it will be transferred from the CD to it will transfer to the main memory and then it will slowly it will execute. Okay. So, in that case what happened, I said ki for transferring it is CPU is not transferring, it is the DMA module is transferring, but DMA module also use the same data and address line, for transferring, and CPU also use the same data line. So, there should not be any collision of these two things. So, therefore, when DMA is transferring data, CPU also need to transfer data. So, there should be a mechanism, it will inform the DMA I need to use the data bus. Okay. So, in that case DMA can stop the CPU, not stop, it suspend the operation of the CPU and it can transfer more data, but within only one cycle. Okay. So, now question is when CPU can ask for data line. So, first phase is fetch instruction. When you need to fetch the instruction, so data line may be required, must be required, not maybe, data line will be required, okay, because it will transfer data from main memory to CPU. So, therefore, this point actually DMA can say you delay little bit, okay, one cycle. So, now there is no breakpoint at this point here. Now, why? Instruction is getting decoded, instruction is already in IR, instruction register, and it has to decode it only. So, it does not need any data bus. Okay. So, therefore, there is no breakpoint at this point. So, it decodes and it realized that one of the operand is again memory. Okay. So, it has to bring the data again to the memory, so sorry, in the processor. So, therefore, that time it needs the data bus. So, but data bus is being used by the DMA. So, DMA can ask you suspend your operation. So, that is the point where is actually cycle stealing will happen. So, it will be delayed. Okay. So, now instruction execution happen within the ALU. ALU is within the CPU. It does not need to have the data bus. So, therefore, there should not be any cycle stealing in this position. Okay. So, next is store results. Store results write back means, say suppose I have instruction add AB. AB are the memory location. So, you add it, that is done in execution part within the processor, but you need to store the result to B, because memory that operand value will come to the processor register, it is operated and now results will be stored to B. So, therefore, you need to have to data bus again, you need to use the data bus. So, therefore, this will be another breakpoint. So, therefore, this is the DMA breakpoint where the cycle stealing will happen, where CPU might be CPU will be suspended if there is any DMA. Okay. And this is something interrupt, as I said that it is actually that 4 phase pipeline, it is not actually 4 phase, It may be 6 phase and so on, but there should be last phase is something called interrupt check. Okay. For during execution, if there is any interrupt, CPU will not entertain, only it will attain the interrupt at the last stage when it will check if there is an interrupt, then only it will go. It may not necessary that each instruction, during each instruction there would be interrupt. Okay. So, that is something called interrupt breakpoint. So, exactly whatever written in the stallings I am telling with some explanation.